asymptotes. If a function f of x has a limit for x going to infinity of f of x being equal to a, then we say that f has a horizontal asymptote, namely the line given by the equation y is equal to a. This of course then for x going to infinity. Here you see an example of such a function that has a horizontal asymptote for y is equal to 1 if x is going to infinity. This function is the function f of x, where f of x equals x divided by the square root of x squared plus 1. And indeed, if we take the limit for x going to infinity, we can rewrite this as the limit for x going to infinity of x divided by the square root of x squared times the square root of 1 plus 1 over x squared. And we divide by this factor x in the denominator, the square root of x squared. Of course, that's equal to the absolute value of x, but since x is going to infinity, it's equal to x. And we find that this limit is equal to the limit where x is going to infinity of 1 divided by the square root of 1 plus 1 over x squared. And this 1 over x squared is of course going to 0, so this limit is indeed 1, and we found the horizontal asymptote y is equal to 1. If we take the limit for x going to minus infinity, then everything is going exactly the same way, except that the absolute value of x is now minus x. And we get a limit equal to minus 1. But that implies that there is also an asymptote y is equal to minus 1, but that's a one that we find at the left. So if x is going to minus infinity. A vertical asymptote is something different. F has a vertical asymptote, and now it's a line which is vertical, so it's of the form x is equal to a, if the limit for x going to a from the right or x going to a from the left of f of x is equal to plus infinity or minus infinity. Here it is allowed that the limit does not exist. So it's not necessary that both limits from the left and from the right are equal. For example, if the limit for x going to a from the positive side is plus infinity and from the negative side is minus infinity, then we still say that there is a vertical asymptote at x is equal to a. An example of this. Take for f of x minus 6 divided by x plus 4. Then this function has a vertical asymptote for x is equal to minus 4. Why? Well, because the limit for x going to minus 4 from the plus side of minus 6 divided by x plus 4 is minus 6 divided by a very small number goes to minus infinity. But the limit for x going to minus 4 from the minus side is plus infinity. So we do find a vertical asymptote in x equal minus 4. The function ln x has a vertical asymptote in x is 0, since the limit for x is going to 0, but now from the positive side of ln x is equal to minus infinity. Here we cannot consider the limit for x going to 0 from the negative side, because the domain of ln x is of course the set of all positive x's.